Hi, everyone. Thank you for joining us today. This will be a presentation by GEP, myself and my colleague Pravang Asher. Today we'll be discussing the topic, achieving sustainability targets in the automotive industry. So first of all, very quickly, GEP, as many of you may know, is a global firm specializing in procurement and supply chain, along strategy, software, and managed services. So let me first get into some introductions. I'm Brian Sleeper. I've been in sourcing and procurement for 20 years as of this month, originally from an engineering background. I'm one of our leaders in the automotive and industrial manufacturing vertical at GEP. And as I mentioned, I'm here with my colleague, Pravang.
All right. Thanks, Brian. Hi, everyone. I am Purvang Asher. I am also part of the automotive and industrial manufacturing vertical in GEP, and I have been supporting our clients, helping them solve procurement supply chain challenges over the last 12 years with GEP.
Thank you, Pravang. And before we get started, just a couple of housekeeping notes. All attendees have joined the webinar in listen-only mode. Copies of this presentation will be available after the webinar. And we look forward to getting questions from all of you attending today. So to enter your questions, please use the Q&A window located under the GEP logo on your webinar console. And please remember to hit submit after you've typed your questions. And we will take the Q&A at the end of the session. So, Pravang, let's get started. Sustainability and greenhouse gas emissions reduction are very important topics, across the globe for the health of our globe. And a huge step forward were the Paris Climate Agreements. Coming out of the Paris Climate Agreements, the automotive industry committed to reaching zero net greenhouse gas emissions by 2050 and also set interim targets for the end of this decade. In understanding what that really means, I think it's important to understand what a company, be it automotive or other, looks at when considering the holistic picture of their greenhouse gas emissions. Pravang, can you please help describe the various aspects of greenhouse gas emissions that are being considered?
Absolutely. Yeah. So, greenhouse gas emissions from a very broad perspective, right? They are classified into direct and indirect emissions. And to help companies manage those greenhouse gas emission related risks and opportunities, they are further delineated into three scopes, right? Scope 1, Scope 2, and Scope 3. And Scope 1 are the direct emissions that happen through sources that are owned or controlled by a company. So an example of that is combustion of fuel that is used to run a furnace or a boiler in a company. It's transportation of employees using company-owned assets. So that's Scope 1. Scope 2 are the indirect emissions from energy, generation of the energy that is purchased for companies' own facilities. And then Scope 3 are all the other indirect emissions that are part of a company's value chain. They could be upstream or downstream. They are further divided systematically into 15 categories. And together, Scope 1, 2, and 3, they provide a comprehensive framework for companies to manage direct and indirect emissions.
Excellent. So there's a lot of components being considered here. Specifically for the automotive industry, Pravang, do we have a way to quantify which of these components have the biggest impact? Which ones really should have the focus of the industry to move the needle on their emissions?
Yeah, it's extremely important to understand the impact of each of these scopes of emissions and then draft a strategy around managing or mitigating those emissions, right? So in the next slide, we are talking about how we went about analyzing data. So what we did is we leveraged the Carbon Disclosure Project. The CDP is a non-profit company who has a program which is pertaining to environmental disclosure. And many Fortune 500 or many companies in general are using that program to report their emissions, and they are completing a questionnaire as a part of that program, which is called the Climate Change Questionnaire. So what our team did is we analyzed the responses for certain automotive manufacturers and tier one suppliers. And what we see is the result on the slide over here, right? It's basically an average of emissions produced by those companies that we analyzed. And the results here show that from a scope 1 and scope 2 perspective, which is mandatory to report as of today, um, the emissions are less than 2.5% of their total emissions across the value chain. And the rest of the emissions are basically coming from scope 3. So if a company has to work or achieve its carbon neutrality goals or net zero targets, they will have to focus on scope 3. And within scope 3, there are a couple of categories which will require a higher focus.
So it appears clear that the category 1 and category 11 emissions are the areas of opportunity, the areas of focus, by far the biggest contributors to that total greenhouse gas footprint. As the auto industry is going through this seismic shift to electrification and moving to electric vehicle production, how does the shift to electric vehicles impact the category 1 emissions, the purchased goods and services, Pravang? Will a shift to electric vehicle production achieve the net zero that the automotive industry is targeting?
Yeah, so let's break down the analysis into category 1 and category 11, right? So from a category 1 perspective, that's basically within scope 3, it's pertaining to purchased goods and services. And on the next slide, yeah, this slide, right? So what we started with over here is we first of all mapped what is included in purchased goods and services. So all the distinct parts, components, vehicle systems that make up of the direct materials, raw materials that make up of the purchased goods and services. And then to that, we added obviously the indirect materials or indirect goods and services as well. Using that as a starting point, we made a base assumption of, let's say there is a company who's manufacturing 1 million vehicles, and it's manufacturing 1 million internal combustion engine based vehicles as well as 1 million of just electric vehicles. So using the type of materials used, using the quantity of materials used, the value of the materials used, the spend of the material used as well, we calculated the emissions across all these subcategories within category 1. And as you can see on the slide, right, there are some materials which will have similar impact, whether it's an internal combustion engine vehicle or electric vehicle. There are some which will have a significant impact, a larger impact in an electric vehicle and vice versa. But accounting for it all, what we can say is electric vehicles, just the act of producing or making electric vehicles would be emitting 1.5 times more emissions versus an internal combustion engine vehicle.
So, first of all, I think this is fascinating research that Pravang, you leading the GEP Automotive team, have done to pull these numbers and these details together and give us this perspective. And I think it may be counterintuitive to some people to realize that the actual production of an electric vehicle drives more greenhouse gas emissions than an internal combustion engine vehicle. One of the things I note here is the assumption that the efficiencies will improve. And by that, I mean the amount of greenhouse gas emissions per unit will decrease over the coming decade. And I know your research showed that that is true for electric vehicles based on the history and the projections that we're expecting about a 23% reduction. But the internal combustion engine production is also getting better at about a 20% improvement. So both will be improving over the next decade, and the evidence suggests that the electric vehicles in production will continue to create more greenhouse gas emissions than internal combustion engine vehicles. So let's take a look at the category 11 emissions, because that I think will be a very interesting comparison over the life of a internal combustion vehicle versus a electric vehicle.
Yeah, certainly. So category 11, right? If we can go to the next slide. So this category is the use of products sold, use of sold products. It's essentially the highest greenhouse gas emission category for automotive industry. And the story is more promising here, fortunately, for an electric vehicle. As you can see that electric vehicles are emitting 1/3 the emissions of internal combustion engine based vehicles. Basically, based on the research, we have two time frames here: the start of the decade and the end of the decade. The start of the decade, it's 1/3 the emissions, right? So that's significantly better than internal combustion engine vehicles. You still see there is some emission footprint there. That's because not all the energy that we consume is coming from renewable sources. This is based on the renewable energy mix in the electricity generation as of most recent time frame, right? So based on that, there is still some fossil fuel related and other sources, non-renewable sources related electricity generated, and that's what's driving some of the emissions that you see in running an electric vehicle versus an internal combustion engine.
Now that makes sense, and I think that is a positive story that the switch of the power generation to more renewable resources will continue to improve the life cycle greenhouse gas emissions of electric vehicles, and even more so in comparison to the internal combustion vehicles. So I think that's a positive shift. But through all of this, what I see and I take away is we're not getting to net zero. There are still emissions both in the manufacturing, there are emissions in the operations. So in that journey to overall reduction, what can we say about how the shift to more electric vehicles over the next decade will influence the total greenhouse gas emissions for auto manufacturers?
Yeah, so as a next step in the analysis, Brian, we just did that, right? We combined the emissions from category 1 and category 11 perspective, and we are focusing on those because they are the maximum impact for automotive industry. So if we read this slide right from left to right, on the left, we started mapping the category 1 and category 11 emissions within scope 3 with the start of the decade 2021, where on an average, this manufacturer is selling 97% of their products, which are internal combustion engine based, and 3% of their products sold are electric vehicles. And then there is a sliding scale which goes towards the right towards the end of the decade 2030. And what it shows is the assumption is that at the end of the decade, that same manufacturer would be having 66% of their products sold via electric, that those would be electric vehicles, and the remaining, so 1/3, would be internal combustion engine vehicles. So what it tells us is over this decade, the same manufacturer will have 45% less emissions compared to start of the decade by primarily improving their product mix, but also to some extent a result of technological advances and taking leverage of those. And just for reference, what we also have shown in the extreme right over here of the chart is what if the same manufacturer was just making electric vehicles, right? And in that case, they would have 65% reduction in the emissions versus the start of the decade. So certainly a big improvement, and certainly helping manufacturers and companies achieve their interim uh, targets, the science-based targets that they have established on the path to net zero. But it's still a long way to go before they achieve net zero by the middle of the century.
Yeah, absolutely. We're still not down to zero on the right there. And just to the level set, all these figures are based on a theoretical million units, million automobiles. Is that correct, Pravon?
Yes, that is correct. Yeah.
Excellent. And I think one of the things that kind of jumps out to me in this graph is almost counterintuitive, is if you look at the category one and the journey through the decade, it actually stays exactly the same at the 6.4 million metric tons. And it's, thinking about that further, that shift to the EVs, even though there's that 20 to 23% efficiencies that we're expecting and greenhouse gas reductions, because the EVs are higher in their total emissions and because there will be more EVs in the mix, it actually balances out. So in that case, where we're making that shift from 3% EV to 66% EV, I see we actually do not see any improvement in the category one. And I think that speaks to some of the challenges that are really facing the automotive industry and meeting those longer term net zero targets. And as you mentioned, the very far right there, all EV, you actually see that category one go up. So I think we should talk about what steps and what actions the auto industry can take to continue this journey, to drive this journey, not only through kind of call it organic is maybe the wrong term, but through the market-driven and also some of the government incentive-driven evolution to EVs will help a lot. 50%, 65% reduction is huge, but it's still not to the point of zero. So I know we laid out a few topics on the next slide to discuss what companies should do, and I think this these apply actually to almost any manufacturing company, although here we are speaking specifically to automotive. So when we think about achieving those long-term goals, getting beyond even what we're showing here, driving beyond that current pace of technology and greenhouse gas reduction improvement in the manufacturing, we think there's some really key steps. You must know where you're coming from. You need to understand your current state, and you need to understand exactly how you're defining your emissions. And I think the framework of the scope 1, 2, and 3, and then the subcategories is really helpful here. And we can see from this analysis and this research why understanding which of those components drive the greenhouse gas emissions will really help the industry know where to focus and where to put their energy to achieving those long-term goals. So speaking of those goals, you have to have targets. You need to be clear. You need to have targets that would be aggressive but yet achievable. And to achieve those targets, you're going to need to collaborate with supply chain. So I think one of the things we can see here, especially in the category 1 targets, those are emissions driven by suppliers, driven by the extraction of the metals that go into be that the rare earths going into the batteries, be that into the components of the vehicle itself. And I think it's going to be very important for automotive manufacturers to collaborate with their supply chain and work on ensuring that their suppliers are also understanding the importance of these targets and driving their behaviors for these targets, and rewarding the suppliers that are aligned with their goals and helping to achieve them. To understand which suppliers are doing that and how you're making progress on those goals, you need reporting and governance. And you're going to need data. You're going to need, at the end of the day, you're going to need systems and software to handle this level of complexity. And I think one of the good news stories is that there are some very strong supply chain software options in the market today, and they're evolving quickly to help companies with both setting the right targets and monitoring the progress against those targets, both within their own walls and very importantly within their entire supply chain. And finally, the infrastructure optimization. That includes a wide range of things, but to continue to drive the EV adoption, there's going to need to be sufficient infrastructure, whether that's charge points, whether that is homes being equipped with the capability to recharge in-house at night. But there's also the infrastructure related to things such as the power grid. The power grid needs to evolve to be ready to take on the additional sources of renewable energy inputs. We've seen some news and information about some of the challenges there, and is going to need to be sophisticated enough to flex to the flow of energy in and out that will be different as the mix of electric vehicles really ramps up.
Yep, and these are great strategies, Brian. Right, that a company needs to formulate. These are the points that they need to include. Right from understanding what they are emitting to the point of establishing targets, and then finally working towards those targets, right? And these strategies are going to impact some key factors, right? Which one of them is the carbon intensity of the manufacturing process, right? Which is going to have a significant impact on the scope 1 emissions as well as the scope 3 category 1 emissions, as the carbon intensity is more efficient through this decade and then beyond. And as you pointed out towards EV infrastructure optimization, the carbon intensity of the electricity that we use to charge our vehicles is going to be critical. It is going to require policy-related government support, infrastructure support for us to be able to get there. And then the technological advancements and the efforts to take your entire value chain together, right? Your supply chain together, collaborate with them to streamline their emissions. Every supplier of an automotive company is not going to have the same wherewithal, right? Same resources to be able to manage this type of a transition effectively, and sharing best practices and collaborating with suppliers is going to be key, so that we all can work towards the pledges that we have made for the middle of the century, or for net zero in general, and we can achieve them successfully and meet our commitments that we have made for this planet.
Yeah, thank you for that, Pravang. And as you mentioned, I think that viewing this as a partnership with supply chains between the manufacturers and then the suppliers and the raw ingredients extractors is an important one. And it's not going to be a passive journey. It's going to have to be a very proactive journey. And I think there'll be a lot of very interesting strategies and approaches developed and standardized in the coming years to really drive this. And I think there'll be a lot of opportunity there for companies to differentiate themselves, for automotive manufacturers to differentiate themselves with how they're working with their supply chain in this space. So why don't we shift to some questions? I see one here. I think ICE have internal combustion engines have some aces up their sleeves. They are just waiting to drop. I'm not quite clear on what is intended with that comment. I could interpret it as an expectation that the internal combustion engine may be being written off too soon, that maybe there's some drastic efficiencies. Maybe there are things such as shifting to biodegradable fuels instead of carbon extraction based fuels, oil. And hopefully there are. I think the more options, the more mix there is in the world to reduce our greenhouse gas emissions, the better.
Yeah, Brian, absolutely. There is another question that has come in. So it's talking about what is the rationale behind our assumptions for emission reductions from 2021 to 2030. So I believe the question is pertaining to in the couple of slides that we had, we were showing the 2021 emissions for category 1 and then 2030 emissions for category 1 and 11. And I believe there were some percentages applied to the reduction in emission for manufacturing the same vehicles, whether it's electric or internal combustion engines. There was a dip in the emission that was seen per unit or for the 1 million vehicles that we analyzed. So what's the assumption behind that, or the rationale behind that is so when we looked at the factors to calculate those emissions, there were multiple sources used. Example, greenhouse gas GHG protocol, right? They have like 50 plus sources listed to be able to calculate emissions, right, based on spend-based, value, quantity-based approaches. So we analyzed the sources and what the emission factors were over the last decade, or in some cases more than that as well, to see what the progress has been. For example, for steel, let's taking that as an example, the emissions would have been X CO2 equivalent per unit in 2010, and they are X minus something in 2021. So using that as a trend and then applying any future trends that could be applicable, we calculated the reductions that we would see in the emission intensity, because of which for the same vehicles produced, let's say electric vehicles, you would have a different and a much lower amount of CO2 equivalent emissions in by the end of 2030 or by the end of this decade versus 2021.
Makes sense. Let's see here. Another question we have. Do you have any data to share on PHEVs and how their emissions compare to ICE?
Yeah, so for PHEVs, again, when we were analyzing the sliding scale, when we looked at the ICE and EV vehicles, we did consider a PHEV mix in there in that sliding scale. So yes, we do have the emissions when compared to internal combustion engines, for example. Let me take the current example right now. So for electric vehicle, as of today, assuming there is no product mix in play, we are seeing electric vehicles would be emitting 50% emissions versus internal combustion engines. And I'm not talking about the use of electric vehicles combined, right, across scope 1, scope 2, scope 3. So PHEV is somewhere between that electric vehicle and the internal combustion engine emissions. The range is around 60 to 70% of the internal combustion engine vehicles when we combine scope 1, 2, and 3. But we may have like detailed information as well over there specific to a certain PHEV, which we can share separately if required.
Yeah, and just before we go on, I will say, if anybody's attending this and you want to follow up directly with myself or Pravong, Clearly, you can contact us on LinkedIn or reach out to us. We're very passionate about this conversation and happy to assist and continue it with anybody outside of this forum as well. I see there's another question here. How do we see impact of emissions as companies partner with battery recycling firms? I think this has been more and more in the reporting and the news, the investments in recycling technology research, the investments in battery construction and chemistries that may lend themselves more towards recycling. And I think our perspective is that this will be important over time. Both from several perspectives: greenhouse gas emissions, there should be a cost benefit, supply chain risk management, in other words, keeping a lot of those rare earths and other materials closer to where you actually want to manufacture them. So many benefits there. I think the challenge that we'll see is more about the timescale when they will have an impact. As we noted, in 2021, mix of EVs was somewhere around 3%. That's a very small percent of the market. The battery life for a current EV battery, depending on whose research you talk to, is 8 to 12 to even 15 years. So what does that say? That says it'll be about a decade out from when a battery is produced to the time that it would likely move into a recycling cycle. And the volume so far has been, fairly low. We expect that volume to ramp up very quickly. There's some other GEP research on the immense number of battery plants being built and the huge, I believe, $60+ billion investment going on in the US alone on that front. So that supply of batteries to recycle will come on market, but we think the real impact is probably going to be somewhere, end of the decade at earliest.
Yeah, that's fair, Brian. And I see one more question out there, right, which is what are the 2 or 3 strategic moves a company or supply chain professional can make? Right, and it's a very good question here. We addressed a little bit of it through some of the content we had, but just to reiterate that, right, one of the most important aspects that the company or a supply chain professional will need to look at is first understanding what is the impact of emissions for categories that we are responsible for. In the one of the slides where we were talking about scope 1, 2, and 3, we were sharing within scope 3 there are 15 specific categories, and of those 15 categories there were 7 or 8 categories which have heavy influence from a supply chain perspective or from a procurement perspective for that matter. So it's going to be important that in our discussions with suppliers, in our overall goals and objectives that we have from a procurement supply chain perspective, we bring this topic up right front and center. We understand what are the emissions by engaging with our suppliers, by getting this information from them, by making it mandatory for them to disclose this, especially for the larger partners that we are engaging with. So those are a couple of things: understanding the impact, measuring the impact, and then working towards establishing a target while working with your sustainability team would be some of the major moves a company could make. Anything else, Brian, you would like to add there?
I would come back to, you're going to need the right tools to effectively manage this. And again, that's going to be some sort of software solution. If you do not feel your organization already has those capabilities, I would suggest looking into the market. Again, it's a rapidly growing focus area for supply chain software and tools creators. So I think that's going to need to be an investment in a lot of companies, is to get the right tools in place to collaborate with suppliers, to monitor these progress on these goals, and to continue to know where to focus energy to have the greatest impact.
Yeah, tools and there are going to be governance processes and systems that could be established, right, for to make this a successful long-term and sustainable, no pun intended, initiative towards achieving your net zero targets. So taking help externally is going to be important. It's not that everyone is going to be able to do everything internally with the resources they have. So certainly that's a great one, Brad.
Yeah, I mean, even down to the details of what's the right contract language to put in place so that both parties are incentivized to reach these goals. So there's a lot of details. There's a lot of learning. It is a very fascinating landscape. Let's move to the next question. How will new regulatory measures affect overall pricing strategy and supplier selection?
Yeah, that's a great question. Again, it's focused on the supply chain aspect there, right? So the regulatory measures, as I understand, I think if I take it broadly, it's about achieving the sustainability targets, right? And there could be certain regulatory measures like the European Union would have its own standards that the countries over there will need to adapt to. But how does it apply from a procurement perspective? And the question is from a pricing strategy and supplier selection angle, right? So more and more companies are focusing on responsible sourcing, on sustainability as a key part of their evaluation process. So we have RFP packages, sourcing events that we conduct, and many companies are basically incorporating sustainability as an evaluation factor, as a criteria, right? And asking suppliers questions about what measures do they plan to take, and those responses are formally analyzed and a part of the scoring criteria, as important in some cases as other qualitative functional factors and pricing factors also, right? So that's how regulatory changes in the sustainability space will have an impact on supplier selection. From a pricing perspective, there is going to be definitely some impact where the products or the parts or the components which are being purchased or services that are being bought would be differently priced if they are coming from a renewable source or more energy efficient source versus a non-renewable source. But again, that's where taking advantage of the technological improvements could help to bridge that gap so that we are at a point where it's not a huge gap to cover for or to achieve net zero, and it organically fits into a company's value chain without a significant cost impact.
And thank you, Pravang. Go to the next question. Are the insights you showed considering new technology in the mix before the end of the decade, perhaps improved hydrogen-powered vehicles? Or are there predictions of emissions reductions based on today's technology only?
Yeah, so for the purpose of the analysis and to keep it focused on the information that is clearly available right now, the insights were based on the today's technology, right? Based on the information that is available right now. So certain aspects such as improved hydrogen-powered vehicles are not considered in the analysis that we have done. We are working on that as the goalposts are moving. We are trying to understand what that impact will be, and then identify a range or some information which can help or drive some insights similar to what we have done for electric vehicles versus internal combustion engine vehicles.
Yeah, and I would also add that particularly for consumer-based vehicles, I think the hydrogen component, while interesting, is even a much greater infrastructure challenge to the EV conversion. We do see some. We think there are probably some good opportunities there in, say things like mineral extraction equipment, heavy industry. Equipment where you have a fleet of large energy using vehicles within a confined space, so you can have that confined infrastructure to continue to support those vehicles. But from a consumer standpoint, so far we've seen the infrastructure challenge be pretty limiting to what we think will be the impact. But as I said before, the more options that are out there, the better. So hopefully there'll be progress and breakthroughs that we don't see yet on that front as well.
Yep. There was one more question there, Brian. It's quite an interesting one there. So I'm going to paraphrase the question a little bit. The question is about what impact would use of AI, for example, have in this space, right? To understand the different scopes and measuring different emission factors. So that's the question. What is the impact of AI, as an example, on the sustainability activities? I have one point to share over there. AI, obviously, that space is ever evolving and changing, but there is a specific example where it could definitely be used, and it's actually being used, right? Where when we calculate or measure the emissions, there are multiple ways. There's a spend-based approach, there's a volume-based approach, there's a hybrid and a supplier-specific approach. Now, when we look at the spend-based, volume-based approaches, that's when the spend of a specific category that we are, or raw material that we are buying, or volume-based approach would focus on the quantity of the raw material that we are buying. So AI can play a big role of analyzing the spend data or analyzing the quantity volume information to apply emission factors for specific subcategories or subcomponents, which currently we may be doing at a much broader level, but AI could help us analyze that and apply the right emission factors without a human having to go and apply that formula or logic, but the system learning by itself and applying it based on the information that is available.
Yeah, I'll go a very different route with that, Pravong, and talk about the infrastructure. The term smart grid has obviously been out there for quite some time. And I think again, that the ability for the very fine balance of energy in and out of the grid is critical for stable grid operation, and something that is getting a lot of attention and some concern in the industry, as the impact of EVs charging, potentially even discharging, feeding back into the grid in times of high demand. As those impacts become much more material than they have been in the past, I think there's an opportunity for AI to significantly improve on some of the software that manages that grid balancing today. So that's kind of a different angle, but without the right infrastructure, this transition to EVs, which we see does have that net large benefit to greenhouse gas emission reduction, that transition will be challenged if the charging and electrical infrastructure cannot appropriately keep up.
100%. Yep. There was a question, Brian, on corporate fleet. There's a question on the TCO of corporate fleets, right, has been going up, and it's going up 20% on an annual basis in the more recent years. And the question is, do we expect TCO for electric vehicles, right, from a corporate fleet perspective, to improve in the next few years as the manufacturers focus on sustainability goals?
So I'll jump in with part of that. First of all, I think the increase we have seen in the TCO, both from purchase price as well as energy costs and so forth, have obviously had some significant impacts from the recent market disruptions. So, I think we may all be past believing there's a new normal, but hopefully some of those disruptions, calm down somewhat. Now, as far as the TCO for electric vehicles on a fleet, that should significantly improve the total cost of ownership, the life cycle cost of a fleet shifting to electrical. I mean, that's why you see, companies such as Amazon switching to last mile delivery via electric vehicles. One of the just anecdotally, in talking to individuals that have transitioned from internal combustion to electric vehicles, one of the common findings is, I don't have to have my oil changed anymore. I don't have to have these air filters changed anymore. I don't have to have my spark plugs changed. Just the level of maintenance is drastically reduced. They're really a much more simple machine than an internal combustion engine, resulting in a lot less maintenance, both preventative and corrective being necessary. And then you add to that the fact that the energy input cost, the gasoline versus electrical, is typically very beneficial. The shift to EVs, I think as fleets become comfortable with them and become able to manage them again and have the right infrastructure for their fleets, I think you'll see a quite rapidly accelerating transition in the world of corporate fleets, be that delivery, be that sales, etc.
Yeah, and with government support through acts such as the Inflation Reduction Act, right? There are certain incentives that are available for from a corporate fleet perspective, commercial vehicles perspective, and if those are continued to be made available and are available for a long term, that's definitely going to further augment reduction of TCO from an electric vehicle perspective. It also is to a lot of extent dependent on the usage of the vehicles, right?
Mm-hmm.
How they are being used, what is the mileage, that is the average running expected out of those vehicles. Those factors, when combined from a TCO angle, they are expected to improve, and at one point they will be very close to internal combustion engines as well.
Yeah, absolutely. It is a situation where a company does need to analyze how their fleet is utilized to understand where the balance is going to be. Totally agree. Here's another question. I think this goes back to something you were talking about earlier, Pravong, that suppliers may not have a similar level of resources to manage a transition of this magnitude to achieve net zero goals. How do we help suppliers to take this journey towards carbon neutrality?
Yeah, it's going to be critical working with your suppliers, collaborating with them. There are many companies who are approaching this innovatively, where they are making funds available for suppliers to transition to renewable energy for their operations. Um, the larger companies have a much better um, uh, leverage from an interest rate perspective, and they have a much lower cost of capital. So making that available to your suppliers for funding specific renewable energy programs or energy efficiency initiatives is one of the ways that companies are helping their supply base out. Um, in addition to that, also sharing best practices, right? Not every supplier is going to come up with an innovative idea by themselves, but if you have a
Mm-hmm.
supply base and there is one of the suppliers uh, who's outshining everyone by exploring different initiatives, sharing those best practices with the supply base could help as well. and is being approached by many companies. There are workshops that companies are doing with their suppliers to sustainability specific workshops. There are councils they are setting up with some of their key partners so that everyone can share what they know and work towards this common goal, right? Not just for companies, but for the planet to mitigate emissions, right, as we go through the end of this decade and through the rest of the century.
Absolutely, and I think even to the point of strategic partnerships with particular suppliers, be that to even help fund things such as research and innovation, or to develop make large capital investments with the to support your suppliers in that way, and there historically have been models similar to that, especially on the direct side of procurement and inputs. But I think that's going to also help certain companies that find the right place to put their money, certain large companies such as the auto manufacturers, move ahead and move faster than their competitors, because they will have a supply chain and supply partners that are able to move faster through that joint partnership. And as Pravang, you were saying, it's not only about the money. A lot of it is about the ideas, the collaboration, getting and making sure those ideas are shared, between suppliers as well. Let's see here. Well, another question. Is the automotive industry aligning on the requirements and incentives for their suppliers to reduce emissions?
Yeah, so overall as an industry, there's not like a single standard or alignment between all the companies. Companies are in different maturity phases right now, right, from a sustainability to achieve their net zero targets. But in general, what the industry is doing is from a requirements perspective, right? They are laying out the requirements for their suppliers based on their own pledges that they have made. So if an auto manufacturer has said that they will be fully carbon neutral by 2050, which includes scope 1, scope 2, scope 3, they have started gathering information from their suppliers for, let's say, scope 3 category 1 emissions, and they have started even setting targets for them, because to achieve net zero by 2050, it's not going to happen overnight. There are some science-based targets, interim science-based targets that have been set. So companies are sharing those targets with their supply base, in some cases larger suppliers, but in some cases with their entire supply base, so that they can show the path that they are taking towards achieving those goals. So yes, there is some standardization of the requirements, but it's happening at a company level, not overall at an industry level right now. And incentives as well. The incentives that companies are sharing is, if a supplier is able to show their commitment towards sustainability, it could enable them to become a preferred supplier. They could be a preferred supplier today, but they would continue to be one. In fact, business could be expanded with them. So those type of incentives are being discussed. Could be added as a contractual measure also. So yes, those discussions are happening, but different levels of maturity across the companies in the automotive industry.
So another question here: how do companies ensure that they're taking advantage of technical advances? And I'll start here, Pravang, and if you have anything to add, go ahead. One of the things that we're seeing, and I think from my perspective is very important, is to enable the resources, the decision makers in the company, the time, the flexibility to be aware of what those technical advances are. A lot of times that's a combination of engineering teams and procurement teams, particularly when you're talking about the inputs to your final product. And one of the things we have seen happening are large manufacturers actually establishing strategic teams within procurement and engineering for the focus of the transition to EVs, and perhaps doing some reconsidering of their traditional structures of procurement and how work is done and who's doing it, to take some of the less strategic, more tactical work off some individuals, again, so that they can have that time freed up to be flexible, to be nimble, to be doing the research of what is available in the market, what is coming down the pipeline, how do you incorporate that into your own supply chain, into your own products, and making that investment in their capabilities to do that. An obvious other one is work with third parties who have the visibility across various industries, across various companies, getting that outside perspective. And of course, even things such as, conferences, periodicals, stay up on the research. And I think that's monitor your competitors. I think those are all ingredients to ensuring you're taking advantage of both the technology that's here today, but that you're ready to take advantage of the technology that is coming in the future. And another aspect of that is, back to being nimble. We don't always know what technology is going to be successful in the future. So how do you set up a product development pipeline, a supply chain infrastructure that will be able to flex when the new successful technology becomes mature enough to utilize, and to flex away from a technology you thought seemed promising but maybe doesn't come to maturity in the timelines you expected.
Absolutely, Brian. Yep. And I think we are almost at the end of our time, right? So just wanted to share some key takeaways, and Brian, feel free to add there, right? I hope the discussion was insightful for the audience. I know the focus was on automotive industry, but a lot of takeaways that we shared, and the percentage share of emissions across different scopes, they apply to other industries. The percentages may vary slightly, but the concept and the fundamentals remain the same. The processes and the strategies to achieve net zero also is very similar. But if someone from any other industry, if you have any specific questions, as Brian mentioned, feel free to reach out to us. We'll connect you to the right experts in our company who would have that information. And I think if we look at the overall sustainability aspect, right, it's going to be a concerted effort that will have to be made across everyone, so that we achieve the targets that we have set for ourselves, so that we can do the right thing for the community and the planet that we are on, and achieve the goals to mitigate the climate change related impact.
No, thank you, Pravong. And I would just add a couple of my takeaways from this is the importance of having a data-driven approach, both in target setting and the monitoring and governance. The importance of that, supply chain partnership with your suppliers, with your logistics providers, et cetera, and ensuring alignment on those targets. And the other key takeaway from me is there's some reasons to feel pretty good about progress that can be made in the next decade, but there's a whole lot of challenges that are coming after that and will need to be overcome to achieve the level of greenhouse gas reduction that is seen as necessary for the planet, over the coming decades into, say, that 2050 target. So we need to make the most of what we see we can do today, and we need to keep looking ahead to think about how do we set ourselves up for further progress, even 15, 20 years out. Thank you all for your time. Thank you for your questions. And I think with that, I believe we've come to the end of our presentation.
Thank you.
Thank you.